Hi students, now we are going to discuss a new topic, namely thermoelectric effect, which is also called as Seebeck effect. What is actually thermoelectric effect? It is the temperature difference between two junctions can be converted into corresponding voltages. This was first observed by a scientist namely Seebeck. So it is also called as Seebeck effect. Now let us consider a closed loop formed by taking two dissimilar materials, namely copper and iron. So take two separate wires, one made up of copper, the other one is made up of iron, joined at the two end points, so that you will get the two junctions at the two end points. So the left side is junction 1 and the right side is junction 2. If you take a thermometer and touch at these two junctions, they will show the same temperature, that is equal to the room temperature. Okay. Now the number of electrons available per unit volume, we call it as electron density. That will be different for two different metals. Is it not? Copper will have different electron density than that of iron. As a result, the electron density across the junction will be different. So naturally there is a tendency for the free electrons to migrate from a higher concentration to a lower concentration. So there is a flow of free electrons within a very small distance of around a micrometer. Understand? 1 micrometer. So in that small distance across the junction points, here as well as junction 2 also, the electrons will migrate from a region of higher concentration to a lower concentration. As a result, at the two junction points or across the two junction points, potential difference will be created. So this potential difference at the junction 1 is V1 and the potential difference across the junction is V2. Okay? And these electrons will not travel throughout the entire loop. Throughout the entire loop, the electrons cannot travel. Only across the junction, within a micrometer distance, the electrons will migrate from one material to the other material, from one side of the junction to the other side of the junction. This creates a potential at the 2 points called as junction potential. So V1 and V2 are called as junction potentials. Now, since the temperature that is at same temperature, okay, at same temperature at both the junctions, at same temperature, this V1 will be equal to V2. So V1 difference V2 is equal to 0. Therefore, the EMF generated will be equal to 0. There is no EMF in the circuit. Okay. This is the first observation. Now in the second picture, I have connected a galvanometer across the copper wire. Okay. And then junction 1 is kept in contact with a hot source like a flame. So that here temperature T1 and here the junction 2 is kept in contact with cold ice. So that junction 2 is at a temperature T2. So T1 is greater than T2. So in the second picture, what I have created is a temperature difference. This temperature difference only is converted into corresponding electrical voltage. This only is called thermoelectric effect, isn't it? So what was observed by Seebeck now in the second picture? Now since the temperature at the hot junction is greater than the temperature at the cold junction, the number of electrons migrating from one end of the junction to the other end will be different. So at the two junctions, in the earlier picture at the constant temperature, same number of electrons only were migrating across the junction. So there was no net EMF since V1 is equal to V2. But when you create temperature difference across this two junctions, what is happening? Across one junction, more number of electrons will migrate. Comparatively, in the other junction, less number of electrons only will migrate. So now the contact potential or the junction potential V1 and V2, V1 is not equal to V2. and this difference in potential V1 minus V2 will be equal to the net EMF in the closed loop. Understand? This was first observed by Seebeck, and this only is called as the Seebeck effect. Okay, now this closed loop consisting of two dissimilar metals like copper and iron. Otherwise, we can take antimony and bismuth, Sb antimony and bismuth, lead and tin, like that two dissimilar materials if you take means, then this closed loop which is made up of two dissimilar metals, this is called by the name thermocouple. This only is called as a thermocouple. In a thermocouple, when the two junctions are maintained at two different temperatures, an EMF will be developed. This EMF developed, okay, EMF developed is also called as thermo EMF. Since an EMF is developed in this closed loop, since it is a closed loop, a current has to flow in the circuit. It is a closed circuit now. So it is found, it was observed by Seebeck that the current was flowing from the copper to iron at the hot end. At the hot end, the current will flow from copper to iron, and at the cold end, the current will flow from iron to copper. This current is called as a thermoelectric current. So the current due to the thermo EMF is called as a thermoelectric current. So my dear students, you should know that this closed loop is called a thermocouple, and the EMF generated in this loop is called as a thermo EMF, and the current flowing through the closed loop is called as thermoelectric current, and this effect only is called as a thermoelectric effect or a Seebeck effect. So as I told you, what is more important here, the two junctions must be maintained at two different temperatures. So this temperature difference only is converted into corresponding EMF, and this effect only is called as a thermoelectric effect. Okay, suppose if junction 2 is made hot and junction 1 is made cold, what will happen? Then also the same effect will be observed, but the direction of current will be reversed. So when the junction temperatures are reversed means the direction of the thermoelectric current also will be reversed. Hence, this effect is reversible. So Seebeck effect is reversible. Understand what is the meaning of Seebeck effect is reversible means what? When the two junctions temperatures are interchanged, then the direction of current. In this picture, can you see junction 1 is hot and junction 2 is cold, and the current is taking what? Anti-clockwise current. Understand? Suppose if the junction temperatures are reversed means then the current will take a clockwise loop. Understand? Now there are some applications. Applications of this Seebeck effect. So it is used in thermoelectric generators. So to convert the waste heat into electricity in power plants, thermal power plants, they are using this. And it is also used in automobiles. So in automobiles, what is the purpose of using this thermocouple? It is used to increase the fuel efficiency of the automobiles. And also it is used in thermopiles. What for means and thermocouples also. So in thermopiles it is used to measure the temperature difference between two materials. So my dear students, I hope you must have understood what is Seebeck effect, and also you must remember the applications of Seebeck effect. Okay.